Okay, so this is the software that we will be using to generate the sine table. The name of the software is called Sine Smart. Okay, so now I will be showing you how we can generate the sine table. So remember what we said that we needed. Okay, the value which we will send to our duty cycle register, the degree which is angle 90 that we want to generate for the rising before decreasing, okay, and the number of samples that we need. So here, this is the number of table entries which we say that is going to be what, 50. So we are going to input our 50. I'm going to explain what this thing does. So here that they said peak value is the amount of the highest value that we choose for the duty cycle, and we say that our microcontroller is an 8-bit which can contain 255. So our timer is going to be 255, which is 10 kilohertz based on the configuration. Then the value which we are going to load to the duty cycle register, we are going to divide, because that duty cycle register is also an 8-bit register which is also 255, but we are going to divide it into 2 because of we are going to use the half of it for the feedback. Okay, so which we say that is going to be 125 in our own case. So we are going to input 125 here that is set peak value. Then this is the angle which we say we are going to generate. You will, on the screen you will see the angle, the rising angle we are generating. So we say it is a angle 90. If we are to go for this angle 180, we are going to get a complete curve of the first waveform, but we are going for the quarter, okay, which is half of angle 180, which is we are going for angle 90. So we are going to input angle 90 here. Okay, look at the values that we input. This is the sample, the number of samples we need, which is 50 here. Here is the value we are loading to the duty cycle register. Okay, while here is the angle waveform we are generating. So if we click on calculate, you will see, look at it, look at this screen now, you will see that this is only half of the 180 degree waveform. This is it here. So this 50 shows the index number, which is the number of samples. And these values you are seeing here, you look at, we said our peak value is 125. This software is going to generate numbers, and it won't exceed 125 that we say that we are going to load to our duty cycle register. So if you count these numbers here, you will see that this number is total of 50 numbers. If we are to count this 0, 4, 8, 12, if any of you have been using arrays, you know the way arrays work, the index number of array. Okay, we are going to create an array for this sine table. So this number, these values you are seeing here, is the value that will be loaded to the duty cycle. So at first, which is this 0 section, now we load the 0 count, the duty cycle will be at 0. After 10,000 count from the timer, we update the duty cycle, loading the duty cycle with this number 4. Okay, after another 10,000 count from the timer 2, which we create an interrupt, then our interrupt will now update the duty cycle register, loading this value 8. So these numbers that you are seeing that we are loading here is the percentage of the duty cycle, is the way we adjust the duty cycle while increasing it. Okay, so why this 125 is the maximum we can load. Okay, so this is how it works. So even though I input 100 or 200 as the entries, what this software will create is that it will create 100 number. Okay, let me show you now. remember, if you count these numbers that is here, you will see that we are having 50 numbers, 50 index, as in 50 numbers. Why the individual number are the value that is being loaded to the duty cycle register. So let me reset this, let me clear this, and let's see, let me show you now. Let me put this thing to 200. Our entries, our sample 200, and we are still maintaining the 125, which we can load to the duty cycle register. Let me calculate now. If you look at this number, you will see our maximum number still remains 125, but the only difference is that we have too many number, which is, if you count this number, it is up to 200. And if you look at our waveform, it is more cover, the curve looks more smoother than the 50 that we generated. So if you want to create a more pure curve, you have to have quite a number of entries. But before you input these samples, make sure that these samples is what your microcontroller can handle. But because we are using an 8-bit microcontroller, we don't want to overload the microcontroller. We have to keep these samples to 50. Okay, so I hope you understand the difference between these samples, this sample and the value we are loading to the duty cycle. Okay, I hope it is clear now. So let's maintain the 50 that we are using before. Okay, so that it will reduce the number, so that it won't lag our microcontroller. Then let's assume we are creating a full curve, which is 180. If we input 180 here, 180 degree, you will see that this software will generate a full curve of 180, still maintaining the numbers. Okay, you see it, but it will alter the way the number works. So if we use this method, we won't get a good sine wave. It will manufacture. Just look at the way the timetable is being arranged. You will see that it will give an error. It won't get the type of sine wave we are looking for. So we have to maintain the 90-degree angle, so which is this, and you can see we will still maintaining our 125 maximum value for our duty cycle register. So this is how to use this software. The name of this software is Sine. You can use this software to generate your sine curve. Okay, so let's go to the programming aspect, and let me explain the programming aspects. So remember this value, but in my own program I'm going to use, what I use is, I'm going to use 100. Okay, so that means I need 100 numbers. I hope you understand what I mean by these samples and the value we are loading to the duty cycle. So this is what I'm going to use in generating the sine curve. So let's go to the software and program this thing and generate our first SPWM.